equations. So the variable x and y and t satisfy the differential equation. I'm just rewriting it here. And so the first step is to separate the variables. By the way, 11 marks, crazy. Okay, so the first step is to separate the variables, everything with x on the left, everything with t on the right. So just multiply both sides by dt, and we divide both sides by this guy here. Okay, so we just move, basically we swap these two expressions here. Okay, so this is what we're trying to integrate, and we have to use partial fractions decomposition for this guy here. So now we're doing the partial fractions. So for this expression or this fraction here, we have to identify the forms we have to use. For the x squared, we can use the unfactorizable quadratic form, or we can use the repeated linear form actually. So here I'm using the unfactorizable quadratic form, and for this is of course the simple linear, and we multiply both sides by the denominator so they cancel out on the left, and on the right when we multiply they cancel out. We have ax plus b times 1 plus 2x, and when you multiply this you cancel out, we have c times x squared. Alright, so now we need to split the coefficients a and b here. So we do ax times 1 plus 2x and b times 1 plus 2x. So we're gonna split the a and the b in different terms like this, and now we cleverly choose the right values of x so we can find a, b, c as quick as possible. So here we can use x equals minus 1/2, because when we plug in minus 1/2, on the left there's nothing to plug in. On the right, when we plug in minus 1/2, we're gonna get 0 here, because it's gonna be 1 plus 2 times minus 1/2, which is 0. Same thing here. So two terms will go to 0, which means we can find the c directly. So that's why we plug in minus 1/2. So when we plug in minus 1/2, we're gonna get positive 1/4, and therefore c equals 4. And then we plug in x equals 0, because this is also the 0 of one of the terms here, the 0 of this term here. So there's nothing to plug in on the left. On the right, when we plug in 0, this whole term goes to 0. Okay, and when we plug in 0, we're gonna get 1 here, 1 times b. When we plug in 0, actually this will be 0 also. Alright, so now we can find the b, and since we have the two coefficients, to find the last coefficient we can just plug in anything random and simple, such as 1. So there's nothing to plug in on the left. On the right, we plug in the x is 1, and when we plug in this 1, we're gonna get 3, and we plug in this 1, so it's gonna be 3 times b, but the b is 1, and here we plug in 1, we get just 1. The c is 4, so we can find the a. So this is 3a, this is 3 plus 4, which is 7. Subtract 7 from both sides, divide by 3, we get a. Okay, so now we can express this fraction into these two partial fractions. Alright, so back to the differential equation here. This is what we were trying to integrate. We replace this left hand side here with the partial fractions, and now we integrate. So for the left hand side here, to integrate this, we're just going to split the fraction further more here. So we split this fraction, we get minus 2 over x, or minus 2 times 1 over x, and from here we get 1 over x squared, or x to the power of minus 2, and from here it's just 1 over 1 plus 2x. And when we integrate nothing, this means there's 1 here. So for the integral of 1 over x, that's going to be ln x because of the MF19 formula here. And for the integral of x to the power of minus 2, we use this rule. We have x to the power of minus 1 over minus 1. And for this guy, again, we use ln, but at this time we divide by 2 because of the chain rule, because of the derivative of this 1 plus 2x. Okay, the derivative of 2x is 2, so we divide by 2. So actually we do that also here, but if we divide by the derivative of x, that's just 1, so it's not necessary. Okay, so the right hand side, the integral of 1 dt is just t. Don't forget the constant of integration, just once only on the right. So now we have the general solution of the differential equation. To find the particular solution, to find the c, we plug in the boundary condition when x is 1, t equals 0. So we replace the x with 1, x with 1, x with 1, t with 0, and we can find the c. ln 1 is 0, so it's just minus 1, and from here we get 3, and this is just 0, so c is minus 1 plus 2 ln 3. So now that we have the c, this is called the particular solution. Now, because we need to read the instruction here, t in terms of x, so since we need to make it t in terms of x, just move this to the left, or we add 1 to both sides, subtract 2 ln 3 from both sides, so we get this on the left. Alright, and now we simplify. So first of all, we can move this 2 inside the argument. It becomes the power of the argument 3 here, so we get 3 squared. And we do the same thing with this 2, we move it inside, so we have x squared. Same thing with this 2 again, we move it here, we have square. And then we combine the ln's here, so this is obviously 9. Okay, so if it's negative, put it in the denominator. If it's negative, in the denominator. If it's positive, it's in the numerator. So this is because of the rule, addition becomes multiplication, subtraction becomes division if we combine the logarithms. Okay, so this is positive, put it in the numerator. This is negative, you put it in the denominator. So 9 and x squared. Alright, after we combine the logarithms, we get this. And yeah, well, this is actually 3x all squared, so we can actually combine it like this also. Right, this is in the simplest form, t in terms of x. That's it, I'll see you again next time.